On land, life follows rules. Eat sunlight, or eat something that did. Breathe air, avoid being eaten. But 3 miles down, in a world without dawn, without plants, without escape from crushing weight, those rules shatter. What replaces them are some of the most ingenious and bizarre survival strategies on Earth. This is not a world of monsters, it is a world of inventors. Above 200 meters, the ocean runs on sunlight. Phytoplankton turn light into sugar. Fish eat plankton. Whales eat fish. A simple, powerful chain. Below 1,000 meters, that chain breaks. No light means no photosynthesis. No photosynthesis means no plants. And yet, the deep sea is not empty. It is full. The question is, what fuels it? The answer falls like snow. Dead algae, waste from surface fish, fragments of molted skin. Scientists call it marine snow. It drifts for weeks before reaching the abyss, and for everything living down here, this sparse, unpredictable dust is the difference between life and death. When food arrives once a month or once a year, you cannot afford to chase it. So many deep-sea creatures have become masters of stillness. The sea cucumber inches across the abyssal plain at a pace slower than a growing fingernail. It doesn't hunt, it doesn't search, it simply processes whatever the current brings. Its body is a slow-motion conveyor belt of sediment. The frilled shark, a living fossil unchanged for 80 million years, conserves energy by moving like a snake underwater, long, undulating, almost lazy. Its metabolism is so slow that scientists believe it could survive for months on a single meal. In the deep, patience is not a virtue, it is a biological requirement. But some creatures take the opposite approach. They grow massive. This is a giant isopod. Its shallow water cousin fits on a fingertip. Down here, it can reach 16 inches, longer than a newborn human. The same pattern appears again and again. Giant amphipods, giant squid, and even giant single-celled organisms the size of a plum. Scientists call this deep-sea giantism, but no one knows exactly why it happens. One theory, larger bodies are more efficient at storing energy between rare meals. Another, larger animals lose heat more slowly in near-freezing water. A third, the absence of predators at certain depths allows slow, steady growth over centuries. The Greenland shark, one of the giants, may live 400 years. It grows less than a centimeter per year. At that pace, size is not ambition. Size is simply what happens when nothing kills you. If you cannot rely on the sun and you cannot rely on speed, you might do something stranger. You might become the light. Nearly 3/4 of all deep-sea creatures produce bioluminescence. They carry chemical factories inside their bodies, luciferin and luciferase, that produce cold light. No heat, no waste, just instant, controlled glow. Some use light to hunt. The stoplight loosejaw produces red bioluminescence, a color most deep-sea animals cannot see. To its prey, the fish is invisible. To the fish, the prey is illuminated like a target in a private spectrum. Others use light to confuse. The siphonophore, a colony of thousands of specialized clones working as one, flares bright blue when touched. Scientists believe this acts as a burglar alarm, attracting a larger predator to attack whatever is attacking the siphonophore. Light as a scream for help. And some use light to hide. The counter-illuminating octopus produces glow on its underside, matching the faint sunlight filtering from above. From below, its silhouette disappears. It becomes invisible by becoming brighter.
At 2,500 feet, a fish called the barrel eye solves a different problem: how to see without being seen. Its eyes are two glowing green orbs inside a transparent, fluid-filled shield. They rotate. They look up through its own forehead to spot prey silhouetted above. This is not science fiction. This is evolution. Not every problem involves hunting or hiding. Some are more basic. How do you find a mate when the ocean is endless and dark? The anglerfish has an answer both elegant and disturbing. The male is born tiny, with no lure, no hunting skills, no ability to survive alone. His entire body is built for one task: find a female. When he does, after drifting through miles of empty water, he bites into her skin and never lets go. His jaw fuses to her body. His digestive system atrophies. His brain shrinks. He becomes nothing but a sperm-producing organ, fed by her blood for the rest of his life. It is not romance, it is survival. Even death itself becomes an opportunity. When a whale dies and sinks, its body creates an entire temporary ecosystem. First come the scavengers: sharks, hagfish, amphipods that strip the flesh. Then come the bone eaters, osedax worms with no mouth and no gut. Only root-like tendrils that dissolve bone and feed on the fat inside. A single whale fall can support life for 50 years. After the bones are gone, even the bacteria that break down the remaining minerals leave behind chemical traces that feed other creatures for decades more. A death becomes a reef. But the strangest solution of all lies not in death, but in the earth itself. Hydrothermal vents tear open the ocean floor, spewing water hot enough to melt lead. No sunlight reaches here. No marine snow falls in meaningful amounts. And yet, the vents are crowded with life. The key is chemistry. Bacteria inside the bodies of tube worms convert hydrogen sulfide, a chemical lethal to most surface life, into energy. They don't need sun. They don't need oxygen in the traditional sense. They need poison. This discovery in 1977 rewrote biology. It proved that life could exist independent of sunlight entirely, and it opened a door to a larger question. If life works this way on Earth, why not on Europa or Enceladus, worlds with dark, hidden oceans and geothermal vents of their own? For all we have learned, the deep sea remains mostly unknown. More than 80% of the ocean is still unmapped, unobserved, unimagined. Each time a remotely operated vehicle descends into a trench, it brings back animals never seen by human eyes. Transparent jellies with no obvious organs, worms that glow in colors we cannot name, fish with faces that look like melted wax. These are not monsters, they are survivors, each one a testament to what happens when life is forced to solve impossible problems. We have sent probes to Mars and Venus. We have photographed black holes billions of light years away. But the deepest point of our own ocean, the Mariana Trench, has been visited by fewer people than have walked on the moon. The deep sea is not a distant world. It is our world. It regulates our climate. It produces half the oxygen we breathe. And it holds answers to questions we haven't even learned to ask yet. We are only beginning to understand what lives down there. And that is perhaps the most hopeful thing of all.